Welcome, beautiful souls, to Conscious Frequency. I'm your guide through the whispers of the universe, the quiet hum of existence, and the profound depths of our own consciousness. Today, we embark on a journey into the heart of matter, a realm where even the most fundamental particles seem to slumber, and into the vast, enigmatic expanse we call the dark. We'll explore the science and philosophy that connects the infinitesimally small with the immeasurably large, revealing how the universe's deepest secrets might be hidden in plain sight, waiting for us to tune into their subtle language. As you settle into your space, wherever you are in this moment, feel the gentle rhythm of your breath. Close your eyes if it feels right, or soften your gaze. Let the sounds around you become a gentle backdrop. Tell me in the comments below, where are you joining us from tonight? What is the dominant color you sense in your surroundings right now? If these explorations into the wonders of existence resonate with you, consider joining our growing family of curious minds. A gentle click of the subscribe button and the notification bell will ensure you don't miss our future journeys into the profound. It's a small gesture that supports our work and keeps these conscious conversations flowing. Over the next 2.5 hours, we will drift through concepts that bridge quantum mechanics with cosmology, sleep science with philosophical contemplation. Prepare to be gently guided, to let go of the day's urgency, and to simply be present with the unfolding mysteries. Let us begin to explore the sleeping atoms and the mysterious dark. To understand the dark, we must first listen to the quietest songs of existence, the subtle vibrations that even the smallest particles emit, or perhaps refrain from emitting. Let's begin our journey not with a bang, but with a whisper, deep within the heart of matter itself. We're talking about the atom, that fundamental building block we learned about in school. But it's so much more than a tiny solar system. Imagine, if you will, the nucleus, a dense, quiet core. And then, the electrons. They aren't just little balls whizzing around a fixed path, you see, they exist in a realm of probability, like a faint mist, a cloud of potential location. They aren't here or there in a solid sense, but rather everywhere and nowhere simultaneously, until we try to pin them down. It's this state of being, this inherent possibility, that holds a profound, silent energy, a kind of sleeping power. This brings us to the idea of quantum states. Think of it like a ladder. An atom can exist on different rungs, each rung representing a different energy level. The lowest rung, the very bottom of the ladder, is what we call the ground state. This is the atom's most comfortable, most stable configuration, its deepest sleep. It's not actively doing anything dramatic, just existing in its most fundamental, peaceful form. All other states, the higher rungs, are excited states, where the atom has absorbed energy and is, in a way, awake and restless. But the ground state, that's the quiet hum, the deep, undisturbed rest. And here's where it gets truly fascinating. Even when an atom is in its ground state, at its absolute lowest energy, it's not entirely still. Scientists have discovered something called our zero-point energy. It's this residual, irreducible energy that all particles possess, no matter how cold it gets, even at absolute zero, that theoretical point where all motion should cease. It's like a subtle, inherent dream that matter carries within itself. A fundamental vibration that ensures nothing is ever truly, absolutely at rest. It's the universe's gentle reminder that even in stillness, there is a subtle, persistent life. So these sleeping states, these ground states, aren't static moments frozen in time. They're dynamic, governed by these probabilistic fields, these clouds of potential. The atom, even in its deepest rest, is in a constant state of quiet anticipation, a subtle dance of possibilities. It's not inert, it's poised. It's like a seed buried deep in the earth, holding within it the blueprint for a mighty tree, waiting for the right conditions to unfurl. This unseen dance, this potential energy, is the silent pulse of matter. Imagine a perfectly still lake at dawn. The surface is like the atom in its ground state, seemingly tranquil, yet beneath, currents and potential energy are held in perfect, silent balance, waiting for the first ray of sun to stir it. It's a profound stillness, but not an empty one. But what happens when these sleeping atoms begin to stir? What is the nature of this energy that awakens them? And where does it come from in the vast cosmic silence? The stirrings of atoms are often revealed by light. Yet the vast majority of the universe communicates in a language we cannot see, a spectrum bathed in shadow. It's fascinating, isn't it, how much of our reality is built on what we can perceive with our eyes? We tend to think of light as this singular, all-encompassing phenomenon, the very essence of seeing. But in truth, what we call visible light is just a tiny, almost shy sliver of a much grander, more expansive cosmic conversation. Imagine a vast, invisible river of energy flowing all around us, carrying whispers and shouts from the furthest reaches of existence. This river is what scientists call the electromagnetic spectrum. It stretches from the gentle, rolling waves of radio that carry our music and voices across vast distances, all the way up to the incredibly energetic, piercing rays of gamma, born from the most violent cosmic events. Visible light, the colors that paint our world, is just that delicate, narrow band in between, like a single, sweet note plucked from an infinite symphony. And the messengers that travel on this spectrum? They're called photons. Think of them as tiny, indivisible packets of pure energy, like little cosmic delivery trucks carrying information from one place to another. When an atom, perhaps slumbering in the quietude of space, encounters a photon, it's like a gentle nudge, a spark that can wake it up. This photon can be absorbed, giving the atom just enough energy to jump to a higher, more excited state, like a dancer leaping into the air. Or, an atom that's already buzzing with energy might release a photon, shedding that excess, and settling back into a calmer state. It's this constant dance of absorption and emission, this exchange of photonic whispers, that allows atoms to interact, to transform, and ultimately, to build the universe we know. But here's where it gets truly intriguing. That beautiful rainbow we see, the one that dances across a dewy morning or bursts forth after a rain shower, that's only a fraction of the story. The thus unseen frequencies are where so much of the universe's hidden narrative unfolds. Infrared light, for instance, carries the warmth of objects, the subtle heat signatures that tell us about life and energy, even in the deepest night. Then there's ultraviolet, invisible to us, but powerful enough to tan our skin or sterilize surfaces, originating from the sun's intense embrace. And beyond that, X-rays pierce through flesh to reveal the bones beneath, while radio waves, with their long, languid wavelengths, allow us to listen to the distant hum of galaxies. These are all forms of light, just operating on different energetic planes, speaking in languages our eyes haven't evolved to hear. These unseen frequencies, though invisible, are constantly interacting with matter, carrying a wealth of information. Imagine trying to understand a conversation by only hearing a single word. That's a bit like how we experience the universe if we only rely on visible light. Infrared radiation, for example, tells us about the temperature of objects, from the faint heat radiating from a distant star to the warmth of your own hand. X-rays can reveal the internal structure of things, like looking inside a geode to see the crystals within without breaking it open. Radio waves can map out the vast, swirling arms of galaxies and the faint echoes of the Big Bang itself. They are the silent observers, the unseen architects, painting a much richer, more detailed picture of the cosmos than our eyes alone could ever hope to capture. Think of the EM spectrum like a vast orchestra. Visible light is a single, beautiful melody, but there are countless other instruments playing in frequencies we can't hear, each with its own unique song that shapes the cosmic symphony. So, if light, in all its glorious forms, is how we primarily perceive the universe and how its fundamental particles communicate, what lies beyond its reach? What fundamental forces and substances remain veiled in the deep cosmic dark, waiting for us to tune into their silent, profound frequencies? Beyond the dance of photons, the very fabric of existence is woven with invisible threads, forces that shape everything from the atom's heart to the grand ballad of galaxies. So, let's talk about these invisible threads. They're the fundamental forces, the unseen puppeteers of the cosmos. We have gravity, that gentle, persistent tug that keeps our feet on the ground and the moon in orbit. Then there's electromagnetism, the spark of lightning, the glow of a star, the very reason our atoms hold together, allowing us to see and touch and feel. And deep within the heart of atoms, we find the strong nuclear force, a fierce, incredibly powerful bond that holds protons and neutrons together, like an unbreakable embrace. And finally, the weak nuclear force, a more subtle player, responsible for certain types of radioactive decay, a quiet transformation happening at the most fundamental level. These four forces, in their own unique ways, are the architects of everything we perceive. But how do these forces travel? They don't just appear out of nowhere. They're mediated by something called quantum fields. Imagine the entire universe, every nook and cranny, is filled with an invisible, energetic sea. These are the quantum fields. Particles, the little building blocks of everything, are like ripples or excitations in this sea. When a ripple in one field interacts with a ripple in another, that's us experiencing a force. So, when you feel the pull of gravity, you're not just feeling empty space, you're feeling the ripple effect of the gravitational field. It's a universe alive with these subtle, pervasive fields, a cosmic ocean of energy. And what are the messengers that carry these forces across the quantum sea? They're called bosons. Think of them as tiny, energetic couriers. For electromagnetism, the messenger is the photon, the particle of light itself. It's what allows the electromagnetic force to transmit its influence. For the strong nuclear force, the tireless messengers are gluons, aptly named because they've glue quarks together within protons and neutrons. And for the weak nuclear force, we have the W and Z bosons, a bit more elusive, but crucial for those subtle nuclear transformations. These bosons are the silent, constant communicators, ensuring that the universe's fundamental interactions are always in play. Now let's linger on gravity. It's the weakest of the four forces, yet it's the one we experience most profoundly on our everyday scale, shaping planets and stars and galaxies. It's a force that acts over vast distances, a gentle whisper that can be heard across the cosmos. While we understand its effects beautifully with Einstein's theory of general relativity, describing gravity at the quantum level remains one of physics' greatest mysteries. Scientists hypothesize a particle called the graviton, a quantum messenger for gravity, but it's incredibly elusive, perhaps too weak to detect directly. The quest to unite gravity with the other quantum forces is like trying to find a single, unifying melody in the symphony of the universe. Imagine these forces as unseen currents in a vast ocean. Electromagnetism is like the gentle ebb and flow of tides, a familiar rhythm. The strong nuclear force is the powerful, binding cohesion of water molecules themselves, keeping everything together, a fundamental unity. If these forces are the architects of the visible universe, what is the unseen scaffolding that holds it all together? The very substance that allows these forces to act. How do you experience the force of gravity in your daily life, beyond simply being held down? Perhaps it's in the way your coffee cup settles on the table, or the silent descent of a falling leaf. We often think of the void as emptiness, but the cosmic dark is far from vacant. It is a dynamic canvas, pregnant with unseen potential and hidden structures. So, what is space? It's a question that has tickled the minds of philosophers and scientists for millennia, like a persistent whisper in the quiet of the night. Is it simply a vast, unfeeling container, like an enormous, invisible box holding all of existence? Or is it something far more profound, something active? When Einstein unveiled his theory of relativity, he painted a picture of space-time, a unified, four-dimensional tapestry woven from space and time. This isn't a static backdrop, it's a dynamic entity, capable of being warped and curved by the presence of mass and energy, like a heavy stone dropped into a still pond. So, space in this view isn't just there. It's an integral part of the cosmic dance, intimately connected to everything within it. And this space-time, this seemingly empty expanse, is humming with a secret energy. We touched upon it briefly before, this idea of there is vacuum energy, or zero-point energy, on a cosmic scale. Imagine the deepest, darkest ocean trench utterly devoid of visible life. Yet even there's a subtle, inherent energy, a fundamental property of the very fabric of reality. Empty space, it turns out, isn't truly empty. It's brimming with this latent energy, a pervasive, almost invisible hum that underlies everything. It's like the silent potential of a seed, holding within it the blueprint for an entire forest, even before it sprouts. This vacuum energy is a fundamental characteristic of the universe itself, a constant, subtle presence. But the universe's subtle activity doesn't stop there. Even in what we perceive as the most profound emptiness, the vacuum, there's a constant, fleeting dance of creation and annihilation. These are as quantum fluctuations. Think of it like this. Even in absolute stillness, if you look closely enough, You might see tiny, ephemeral sparks of light flicker into existence for a fleeting moment before vanishing just as quickly. In the vacuum of space, its particles and their antiparticles popping into and out of existence, a constant, subtle ebb and flow. It's the universe's gentle, almost shy way of reminding us that even in its deepest slumber, there's a constant, subtle, fleeting activity. And these vacuum energies, these quantum fluctuations, they're not just abstract curiosities. They are, in fact, the very fabric of reality. They are the invisible threads that weave together the tapestry of space-time. This inherent energy within empty space is believed to be the driving force behind the accelerated expansion of the universe, pushing galaxies further apart with an unseen hand. It also plays a crucial role in the formation of structures, the subtle seeds from which galaxies and stars eventually bloom. It's like the invisible currents in the ocean, shaping the movement of water and influencing the journey of every drop. Consider the vacuum like a vast, dark, silken sheet. It appears empty, but it's incredibly elastic, capable of rippling and vibrating, with tiny ephemeral sparks of energy appearing and disappearing within its depths. It's a silent, unseen dynamism that holds the universe together and propels it forward. What does the concept of emptiness evoke in your mind? If the vacuum itself possesses energy, what colossal forces are shaping the grand structure of this empty space, and what does it mean for the matter within it? Among the unseen forces, gravity stands as the grand sculptor, its gentle yet relentless pull shaping the vast architectures of the cosmos from dust to galaxies. And here we are, in Chapter 5, ready to explore the quiet, persistent strength of gravity. It's a force we feel every moment, grounding us, keeping our feet planted on this spinning planet. But its influence stretches so much further, orchestrating the grand ballad of the universe. Einstein, with his beautiful mind, showed us that gravity isn't some mysterious tug across empty space. Instead, it's a curvature, a bending of the very fabric of existence, space-time itself. Imagine space-time as a vast, invisible tapestry. When anything with mass, like a star or even you and me, enters this tapestry, it creates a dent, a subtle warp. And it's this warp, this gentle dip, that guides the motion of everything else. It's not a force pulling, but rather a path being followed, a consequence of the universe's geometry. This subtle bending is the very engine that ignites the cosmos. Think about those vast, ethereal clouds of gas and dust, swirling silently in the interstellar darkness. Gravity, that patient architect, begins its work. It whispers to these particles, drawing them closer, ever so slowly. As more and more matter gathers, the gravitational pull intensifies, and the cloud begins to collapse, spinning faster and faster. At its heart, the pressure and temperature become so immense that a miracle occurs, fusion ignites. A star is born, a luminous beacon in the night. And then, these stars, these celestial families, are drawn together by the same gravitational embrace, clustering into magnificent galaxies, swirling islands of light in the cosmic ocean. And when we zoom out, far beyond the familiar constellations, we see gravity's grandest designs. The universe isn't a uniform sprinkle of stars, it's a vast, intricate, cosmic web. Imagine delicate threads of galaxies and clusters of galaxies, stretching across unimaginable distances, all interconnected by the invisible strands of gravity. These filaments are separated by enormous, almost empty expanses, the great cosmic voids. It's a structure that has been sculpted over billions of years, a testament to gravity's enduring influence, patiently weaving the universe into its breathtaking, web-like form. But gravity isn't just about building, it's also about movement, about the universe singing its song. When truly colossal events occur, like two black holes spiraling into each other, or a neutron star collapsing, they send out ripples through spacetime itself. These are all gravitational waves, the faint echoes of cosmic collisions, a profound confirmation of Einstein's ideas. They travel at the speed of light, carrying information about the most violent and energetic events in the universe, a subtle symphony that we are only just beginning to hear. Think of spacetime as a stretched trampoline. Placing a heavy ball like a galaxy in the center creates a dip, a curvature. And then, when smaller marbles representing stars roll nearby, they don't travel in straight lines. Instead, they are drawn towards the center, following the curve created by the heavier ball, a beautiful, tangible analogy for gravity's invisible hand. While gravity builds the visible structures, what is the invisible substance that seems to be accelerating this cosmic construction project? And why can't we see it? If you could create your own cosmic structure, what would it look like? And what song would it sing? We'll ponder these questions as we move into the next chapter. We've spoken of gravity's pull, but what if the majority of that gravitational influence comes from a substance that is utterly invisible, a silent, pervasive presence? It's a thought that truly humbles the mind, isn't it? We look up at the night sky, at the pinpricks of light that are galaxies, and we feel we're seeing the grand tapestry of the cosmos. But what if what we see is just the shimmering surface, and beneath it all, there's a vast, unseen ocean of something else entirely? This is the realm of dark matter. The evidence for its existence isn't a whisper, it's a chorus. We see it in how galaxies spin. Their outer edges whirl with a speed that suggests far more mass is present than the visible stars and gas can account for. It's like watching a merry-go-round spin, but the horses on the edge are moving just as fast as those in the center, defying the usual rules of physics, unless there's unseen weight holding them in place. Then there's gravitational lensing. Imagine light from a distant galaxy bending around an invisible mass, creating distorted, sometimes multiple images. It's as if the universe itself is a giant, imperfect lens, and the distortions reveal the presence of something massive, yet invisible. The faint echo of the Big Bang, the cosmic microwave background radiation, also carries imprints of this unseen substance, showing us how it influenced the very early structure of the universe. And in the grand dance of galaxy clusters, the way they hold together, the speed at which they move, all point to a gravitational force far stronger than visible matter alone can provide. So, if it's not the stars, not the gas, not the dust, what is it? We can confidently say that dark matter isn't made of ordinary baryonic matter. That's the stuff we're made of, the protons, neutrons, electrons that form atoms. It's not the faint glow of photons, the particles of light, nor is it the elusive, nearly massless neutrinos that zip through us constantly, though they do contribute a tiny fraction of mass. If it were just more of the stuff we understand, we'd see it interacting with light, absorbing it, emitting it, or reflecting it. But dark matter is, well, dark. It doesn't seem to interact with light in any significant way, making it stubbornly invisible to our telescopes, which are designed to capture the electromagnetic spectrum, the language of light. It's as if the universe has a secret ingredient, something that doesn't speak the same language as the rest of existence. This leads us to the fascinating, speculative realm of hypothetical candidates. Scientists have proposed various particles that could fit this cosmic bill. One of the leading contenders are EMPs, or weakly interacting massive particles. The name itself hints at their nature. They're massive, contributing to gravity, but they interact very weakly with normal matter, and crucially with light. Think of them as cosmic ghosts, incredibly heavy but able to pass through walls, or rather, through us, without us ever noticing. Another intriguing possibility is the axion. These are hypothesized to be extremely light particles, far lighter than electrons, but if they exist in vast numbers, they could collectively contribute the necessary mass. They were originally proposed to solve a different problem in particle physics, but their properties might just make them the perfect dark matter candidates. There are other ideas too, like sterile neutrinos or even primordial black holes, but EMPs and axions currently hold the spotlight in this cosmic detective story, and the role of this invisible architect is profound. Dark matter isn't just a passive passenger, it's the scaffolding upon which the universe was built. In the very early moments after the Big Bang, the universe was a hot, dense, relatively uniform soup, but there were tiny fluctuations, ripples in density. Dark matter, being unaffected by the outward pressure of radiation, began to clump together under its own gravity. These clumps acted as gravitational wells, invisible attractors that pulled in ordinary matter. Think of it like this: dark matter was the invisible hand that began to gather the stardust, the gas and plasma into denser regions. These regions then collapsed further, igniting stars and eventually forming the galaxies and galaxy clusters we see today. Without dark matter, the universe would likely be a much more diffuse, less structured place, perhaps without galaxies like our own Milky Way. It's the silent, unseen glue that holds the cosmic web together, the foundation upon which all visible structure rests. Imagine a bustling city at night. The visible lights are the stars and galaxies, twinkling and vibrant. But the entire city's infrastructure, the roads, the foundations, the unseen power lines, the underground pipes, that's like dark matter, holding everything together and enabling its existence and function, even though we don't directly see it. If dark matter is the unseen framework, what is the even more mysterious entity that seems to be driving the universe apart? An enigma even more profound than the dark matter itself. What is your intuition about what dark matter might be? We discovered the universe was expanding, but the most profound revelation was that this expansion is not slowing down, it is accelerating. Driven by a force we call dark energy. It's a thought that settles in, isn't it? Like finding out the gentle tide you've always known is actually being pushed by an unseen, relentless current. For decades, the prevailing wisdom, the comforting narrative, was that the universe, born in a fiery explosion, was still reeling from that initial push, its expansion gradually slowing down under the relentless pull of gravity. We imagined a cosmic brake being applied, a universe gracefully decelerating, perhaps eventually collapsing back in on itself in a grand cosmic sigh. But then, in the late 1990s, a surprising whisper emerged from the data, a whisper that grew into a resounding declaration. Astronomers, peering into the vastness with incredibly sensitive telescopes, were studying distant supernovae, the spectacular death throes of massive stars. These celestial fireworks, when they occur at known distances, act as cosmic lighthouses, allowing us to measure the expansion rate of the universe at different points in its history. And what they found was utterly astonishing. These supernovae, the ones further away, were dimmer than they should have been, suggesting they were further away than predicted by a slowing expansion. The universe wasn't just expanding, it was picking up speed. It was accelerating. This acceleration, this cosmic sprint, points to something we can't quite see, something we've named dark energy. Think of it as the universe's own mysterious propellant. It's not like the familiar forces we know, gravity, electromagnetism. Instead, it seems to be an intrinsic property of space itself, a kind of X-repulsive force that pushes everything apart. While gravity, the great cosmic hug, tries to draw matter together, to form galaxies and stars, dark energy acts like an invisible hand, steadily pushing the fabric of space-time outwards, and doing so with increasing vigor. It's as if the very emptiness between galaxies is imbued with a subtle, persistent energy that's winning the tug of war against gravity on the largest scales. We're still trying to grasp its true nature, its essence, but its effect is undeniable, etched into the expanding tapestry of the cosmos. Now, for a moment, let's revisit a familiar face in this cosmic drama: Einstein. Back in his day, grappling with his equations of general relativity, he introduced something called the cosmological constant, often represented by the Greek letter lambda g. He added it to his equations to counteract gravity, to allow for a static, unchanging universe, which was the prevailing view at the time. But when Edwin Hubble discovered the universe was indeed expanding, Einstein famously called it his biggest blunder. Yet here we are, decades later, and that very same lambda, that seemingly discarded idea, is back. It's been revived, not as a fudge factor for a static universe, but as a leading candidate for what dark energy might be. It could represent the energy inherent in empty space, the vacuum energy that seethes with virtual particles popping in and out of existence. If this is true, then the universe is not only expanding, but the very vacuum of space is imbued with a force that drives this expansion. The implications of this accelerating expansion, this relentless push of dark energy, are profound, painting a picture of the universe's ultimate fate that is both awe-inspiring and, perhaps, a little chilling. If dark energy continues to dominate, as current observations suggest, the universe will keep expanding, and that expansion will keep accelerating. Galaxies will drift further and further apart, eventually receding beyond our observable horizon. Imagine the universe is a balloon being inflated. Gravity is like the rubber's elasticity trying to pull it back, but dark energy is an invisible, constant stream of air, pushing it outward faster and faster. Eventually, the universe could become so vast and so empty that stars will fade, galaxies will become isolated islands, and the night sky, once ablaze with distant light, will grow dark and cold. Some theories even suggest a more dramatic end, a big rip, where the accelerating expansion becomes so violent that it tears apart galaxies, stars, planets, and even atoms themselves. It's a future of ever-increasing solitude. This cosmic dance of dark matter and dark energy suggests a universe far stranger than we imagined. But what about the origins of this cosmic ballet? The very beginning of everything. Before the stars, before the galaxies, before even the atoms we discussed, there was a primordial state, a dense, hot beginning shrouded in a profound cosmic darkness. Imagine, if you will, that very first moment. Not a bang as we typically picture it, no thunderous explosion echoing through empty space. Instead, picture an unfathomable compression, a point of infinite density, and of unimaginable heat. It was a soup, a roiling incandescent plasma, so hot that even the fundamental building blocks of matter, the very particles we've been exploring, couldn't yet hold their form. Electrons, protons, neutrons, they were all a chaotic dance, a blindingly bright, undifferentiated energy, clinging to each other in a furious, energetic embrace. It was the universe in its most raw, most elemental state, a nascent spark of existence before anything had truly begun to be. And then, something extraordinary happened. This nascent universe, still incredibly hot and dense, underwent a period of explosive growth, a cosmic unfurling called inflation. It wasn't an expansion into something, but rather an expansion of space itself, happening at speeds that defy our everyday comprehension. In a fraction of a second, the universe stretched, growing from something smaller than an atom to something already vast. This rapid expansion was like smoothing out a crumpled piece of paper, making the universe remarkably uniform. But it also amplified the tiniest quantum jitters, the almost imperceptible ripples in the fabric of reality. These were these seeds of structure, the subtle variations in density that, over eons, would coalesce into the grand cosmic tapestry we see today. This early energetic universe left behind a faint whisper, a cosmic echo that still permeates the cosmos. We call it the cosmic microwave background, or CMB. Think of it as the oldest photograph we have of the universe, taken when it was just a mere infant, about 380,000 years old. Before this time, the universe was opaque, a thick fog of charged particles scattering light in every direction. But as it cooled and expanded, electrons and protons finally found each other, forming the first neutral atoms. This moment, called recombination, allowed light to travel freely for the first time. The CMB is that first light, the residual warmth of that fiery beginning, a gentle, pervasive glow that's a direct imprint of the universe when it was young, smooth, and just starting to take shape. After that initial burst of light, after the universe had cooled enough for atoms to form, but before the very first stars ignited, there was a period we call the cosmic dark ages. Imagine a universe filled with a vast expanse of neutral hydrogen and helium gas, still relatively uniform, with no bright, energetic stars to pierce the gloom. It was a time of quiet anticipation, a cosmic twilight where gravity was slowly, patiently at work, pulling together those tiny density fluctuations imprinted during inflation. It was a universe waiting for its first flicker of light, a vast, dark canvas upon which the grand story of star formation was about to be painted. Think of the Big Bang like the moment a seed germinates in the dark earth. It's a period of intense, unseen activity, laying the groundwork for everything that will eventually blossom into the light. If this primordial dark was the cradle of everything, how did the first lights, the first atoms, and the first stars emerge from this seemingly uniform expanse? The universe, once a blindingly hot plasma, cooled enough for its fundamental building blocks to finally settle into a more stable, neutral state, the birth of the first atoms. So, picture this, friends. We've been journeying through this incredibly energetic, chaotic soup that was our infant cosmos. Imagine a place where everything was so intensely hot, so incredibly dense, that the very particles we know and love, electrons, and their much heavier partners, the nuclei, couldn't even hold hands. They were like spirited children, running around separately, unbound. This wasn't a gentle mist, it was a scorching, opaque plasma, a universe shrouded in a kind of luminous fog. Light, the messenger of the cosmos, was constantly bumping into these free, roaming electrons, getting scattered in every direction. It couldn't travel far, couldn't carry information across vast distances. It was like trying to see through a thick, blinding snowstorm, where every photon is immediately absorbed or deflected. This state, this energetic dance of separate charges, meant the universe was effectively invisible to itself, unable to truly perceive its own unfolding. But then, something truly remarkable began to happen. As the universe continued its grand expansion, it also, crucially, began to cool. Think of it like a pot of boiling water slowly simmering down. As the temperature dropped, those energetic, free, roaming electrons started to lose some of their wild exuberance. They began to be drawn, like magnets finding their true north, towards the positively charged nuclei, the protons, and the nascent helium nuclei that had formed earlier. This process, this gentle capture, is what we call recombination. Suddenly, these previously separate entities were finding their partners, forming the first neutral atoms. Primarily, these were the simplest of elements: hydrogen, with its single proton and single electron, and helium with its 2 protons, 2 neutrons, and 2 electrons. It was the universe finally learning to build stable structures, to create the fundamental bricks for everything that was yet to come. And this formation of neutral atoms had a profound, almost magical consequence. Remember that blinding fog, that inability of light to travel freely? Well, once the electrons were neatly tucked away, bound to their nuclei, there were far fewer free charges to scatter the photons. The universe, in essence, cleared its throat. Light could finally break free unimpeded. This moment, when the universe transitioned from an opaque plasma to a transparent expanse, is when the cosmic microwave background radiation, the CMB, was emitted. It's like the universe took its first clear breath, and in that breath, it sent out a message, a faint echo of its babyhood, that we can still detect today. It was the universe, for the very first time, truly seeing itself, illuminating its own vastness. So, what was this newly transparent universe made of? It was a remarkably simple composition, really. Predominantly, it was this newly formed neutral hydrogen and helium. Imagine a vast, silent canvas, painted with the most basic of elements. There were no stars yet, no galaxies, no complex molecules. Just these fundamental, neutral atoms, spread out across an ever-expanding space. This was the raw material, the cosmic dust and gas, patiently waiting for the next chapter to unfold. These atoms, these quiet, stable entities, were the seeds from which all the magnificent complexity of the universe would eventually grow. They were the universe's first, the organized thoughts, its initial whisper of form. Imagine a crowded, noisy concert hall. Everyone is talking at once and you can't hear the music. Then, suddenly, the audience calms down, and the beautiful melody of the instruments can finally be heard clearly. That's a bit like what happened. The scattered charges were the noise, and the formation of atoms was the quiet that allowed the true cosmic music, the light, to travel. With atoms now formed and the universe transparent, what subtle forces began to draw this neutral matter together, initiating the slow, grand process of cosmic structure formation? What does the concept of transparency mean to you? The universe had its first atoms, but it was still dark. The next great cosmic event was the ignition of the very first stars, piercing the long night. Imagine, if you will, a universe utterly devoid of light. This was the era we call the cosmic dark ages. For hundreds of millions of years after the Big Bang, the cosmos was a vast, quiet expanse. The primordial soup of hydrogen and helium atoms, newly formed and exquisitely neutral, floated in the darkness. There were no galaxies, no stars, no shining beacons to punctuate the black. It was a universe in its infancy, a hushed breath held before the grand awakening. The only illumination came from the faint, lingering glow of the cosmic microwave background, a memory of a hotter, denser past, now stretched and cooled into invisibility. It was a time of profound stillness, a canvas waiting for the first brushstroke of light. But even in that profound darkness, a subtle sculptor was at work: gravity. It's a force we often feel as a steady pull, but on cosmic scales, it's a patient architect. Gravity began to gather the wisps of neutral gas, drawing them together in the slightly denser regions of the early universe. Think of it like dust motes in a sunbeam, slowly coalescing. These invisible clouds of hydrogen and helium, drawn by gravity's gentle, persistent hand, began to contract. As they squeezed tighter and tighter, the atoms within them bumped and jostled with increasing frequency. The pressure and temperature at the heart of these collapsing clouds started to climb, a slow, inexorable build-up of cosmic potential energy. And then, in the deepest, densest cores of these primordial gas clouds, something truly magical happened. The pressure became so immense, the temperature so high, that nuclear fusion ignited. This was the birth of the very first stars, often referred to by astronomers as population-thirst stars. These were not like the stars we see today. They were likely colossal, hundreds of times more massive than our sun, and blazing with an unimaginable intensity. Composed purely of the simplest elements, hydrogen and helium, they were the universe's first true lights, born from the raw materials of creation. They were fleeting giants, burning through their fuel at a furious pace, destined for a short, brilliant existence. The light and energy pouring from these first stars were so powerful that they began to fundamentally change the universe around them. Their intense ultraviolet radiation acted like a cosmic cleanser, reaching out into the surrounding neutral gas. This radiation was energetic enough to strip electrons from the hydrogen and helium atoms, turning them back into charged ions. This process is called reionization, and it effectively ended the cosmic dark ages. The universe, once a dark, neutral expanse, was now becoming ionized, filled with a faint, pervasive glow from these pioneering stars. It was the dawn of a new cosmic era, where light began to permeate the darkness. Think of the universe as a vast, dark, silent forest. Then, a single, incredibly bright firefly appears, and its light triggers a cascade, igniting countless other lights, transforming the entire landscape. These first stars were that initial spark, a glorious awakening that pushed back the shadows and illuminated the cosmos for the first time. These first stars forged heavier elements in their fiery cores. But as the universe aged and these stars died, what happened to the matter they created, and how did it lead to the diversity of atoms we see today? The early universe was simple, made only of hydrogen and helium. The complexity of the cosmos, the very atoms that form us, were forged in the intense crucibles of stars. Imagine, if you will, the newborn universe, a vast, cool expanse, mostly just the simplest, lightest gases, hydrogen and helium. It's like a blank canvas, or perhaps a quiet, empty room, waiting for something more. But within the hearts of the very first stars, a profound alchemy began. These celestial bodies, these immense, fiery furnaces, became the cosmic kitchens where the building blocks of everything we know were slowly, painstakingly, created. This process at its core is nuclear fusion. It's a dance of unimaginable forces, where extreme gravity crushes matter together, and temperatures soar beyond anything we can truly comprehend. In these stellar cores, hydrogen atoms, the most basic of elements, are forced to overcome their natural aversion to each other and fuse into something new. The primary way this happens, especially in stars like our own sun, is through something called the proton-proton chain. Think of it as a gentle step-by-step process. Two protons, which are essentially hydrogen nuclei, collide and, with a bit of quantum tunneling magic, can fuse. One of the protons transforms into a neutron, and a voilve, you have a deuterium nucleus, a heavier form of hydrogen. This then combines with another proton to form helium-3. Finally, two helium-3 nuclei meet, fuse, and release a stable helium-4 nucleus, along with a couple of protons to keep the cycle going. It's a beautiful, cascading reaction, like a series of carefully orchestrated dominoes falling. In larger, hotter stars, a slightly different process takes over, the AUS-CNO cycle, which uses carbon, nitrogen, and oxygen as catalysts to achieve the same end goal, turning hydrogen into helium. But the story doesn't end with helium. As a star continues to burn through its hydrogen fuel, its core contracts and heats up even further. When the core becomes hot and dense enough, helium nuclei themselves can begin to fuse. This is often called helium burning. 3 helium nuclei in a process known as the triple alpha process can merge to form a carbon nucleus. It's quite a feat, requiring a very specific energy resonance to make it happen. From carbon, further fusion can create oxygen, and in the most massive stars, this fiery chain reaction continues, forging ever heavier elements like neon, magnesium, silicon, and eventually all the way up to iron. Iron is a crucial turning point, a kind of cosmic dead end for fusion, as it requires more energy to fuse than it releases. The mass of a star is the ultimate director of this elemental symphony. A small star like our sun will live a relatively quiet life, fusing hydrogen to helium, and then perhaps a bit of helium to carbon. But a truly massive star, many times the mass of our Sun, becomes a powerhouse of creation. These giants can sustain the incredibly high temperatures and pressures needed to forge elements all the way up to iron. The heavier the element, the more extreme the conditions required. It's a direct correlation. More mass means a hotter, denser core, and thus the ability to create a wider range of elements. Stars are like cosmic alchemists, taking basic ingredients, hydrogen, helium, and, through intense heat and pressure in their fiery hearts, transforming them into a dazzling array of precious elements. Think of a baker, starting with simple flour and water, and with heat and time, creating a complex, delicious loaf of bread. While stars forge many elements, the heaviest ones are made in more violent events. What catastrophic cosmic phenomena are responsible for creating elements like gold and uranium? The most dramatic events in the cosmos, the explosive deaths of stars and the collision of dense remnants, are the true birthplaces of the heaviest, most exotic elements. Imagine, if you will, a star, a true titan among its celestial brethren, a star far more massive than our own Sun. For millions, perhaps billions of years, it has been a furnace, a cosmic hearth, diligently forging elements in its core, from the lightness of hydrogen all the way up to the sturdy resilience of iron. But when its nuclear fuel begins to wane, when the outward push of fusion can no longer counteract the immense inward pull of gravity, a catastrophic implosion occurs. The star's core collapses in on itself with unimaginable speed, a cosmic breath held and then violently exhaled in a supernova. This isn't just any explosion, it's a Type II supernova, the grand finale of a massive star. In this searing, fleeting moment, temperatures soar to billions of degrees, and densities become so extreme that nuclei are bombarded by an overwhelming flood of neutrons. This is where the magic of nucleosynthesis truly ignites, creating elements heavier than iron, elements like gold, silver, and iodine, elements that simply cannot be forged in the gentler fires of stellar cores. Now, let's shift our gaze to an even more extreme cosmic ballet, the dance of neutron stars. These are the incredibly dense, collapsed cores left behind after some supernovae, packing more mass than our Sun into a sphere no larger than a small city. When two of these stellar corpses, these cosmic diamonds, spiral towards each other in a gravitational embrace, the universe holds its breath. As they collide, they unleash a torrent of energy so profound it can be detected across vast cosmic distances as gravitational waves and gamma-ray bursts. Within this maelstrom, matter is compressed to densities we can barely comprehend, and the conditions are ripe for another incredible feat of element creation. These mergers are thought to be a primary source for the heaviest elements in the universe, including platinum, uranium, and even the gold that adorns our necks and fills our vaults. It's a cosmic alchemy of the most violent, yet beautiful kind. The process that allows for the creation of these super, heavy elements in such extreme environments is known as the arc process, or rapid neutron capture. Think of it like this: imagine an atomic nucleus as a small, hungry creature. During a supernova or a neutron star merger, it's presented with an overwhelming buffet of neutrons. The R process is when this nucleus manages to gobble up neutrons much faster than it can digest them, meaning it can't decay back into a more stable form before capturing another neutron. This rapid-fire absorption of neutrons pushes the nucleus into uncharted territory, creating isotopes that are incredibly neutron-rich. Eventually, after the chaos subsides, these unstable nuclei will undergo a series of beta decays, transforming those excess neutrons into protons, and in doing so, they become entirely new, heavier elements. It's a cosmic race against decay, a furious forging of the very building blocks of our universe. And what happens to all these newly minted elements, forged in the crucible of stellar death and cosmic collision? They don't just vanish. These explosive events act as cosmic dispersal agents, scattering these precious elements, from the iron in our blood to the calcium in our bones, far and wide into the interstellar medium. They are like celestial seeds, broadcast across the galaxy, carried on shockwaves and stellar winds. Over billions of years, these elements mingle with gas and dust clouds, enriching them and providing the raw materials for the next generation of stars, and eventually planets. Our own solar system, including our Earth and indeed, every atom within our bodies, is literally composed of stardust, elements that were once part of stars that lived and died long before our sun ever ignited. It's a profound cosmic inheritance. Think of these cosmic explosions as immense fireworks displays. Each burst releases not just light and energy, but also the fundamental building blocks for future creation, scattering them like cosmic dust across the void. These elements, forged in fire and chaos, eventually coalesced into planets like our own. But what is the fundamental nature of the sleeping atoms within our bodies, and how do they relate to this cosmic past? What element do you find most fascinating and why? We are, quite literally, made of stardust. The atoms that comprise our bodies carry the echoes of cosmic furnaces and the silent potential of the universe itself. It's a thought that can feel both profoundly humbling and incredibly expansive, isn't it? When we trace the lineage of every atom within us, the carbon in our bones, the oxygen we breathe, the iron that carries life through our veins, even the calcium that gives our smiles their strength, we find ourselves connected to something ancient and vast. These aren't just random elements. They are the children of stars. Forged in the searing heart of stellar furnaces, from the gentle fusion of hydrogen to the cataclysmic explosions of supernovae, these fundamental building blocks of our very being were cooked into existence across unimaginable gulfs of time and space. Think of it, the very atoms that make up your fingertips were once part of a fiery nebula, swirling with nascent energy, or perhaps even witnessed the final, brilliant gasp of a dying sun. And how did this cosmic dust find its way to us, to this small, blue planet, and ultimately, into the intricate tapestry of our own bodies? After their fiery birth, these newly minted elements were scattered like seeds across the cosmos. They coalesced into vast clouds of gas and dust, the nurseries of future solar systems. Our own sun and its orbiting planets, including Earth, formed from such a cloud, a swirling disk of cosmic debris. As our planet cooled and evolved, these stardust elements, carried on solar winds and captured by gravity, began to mingle, to combine, to form the very stuff of life. They were the raw materials, waiting patiently for the right conditions, the right chemistry, to begin their incredible journey into biological forms. Now, consider the atoms that hum within your cells right now, the carbon, hydrogen, oxygen, nitrogen, the trace minerals. For the most part, these atoms exist in a remarkably stable, almost sleeping ground state. They're not actively doing much, just being. They are the silent, fundamental partners in the dance of life. But when the signals come, when the energy flows, they are ready. They are poised to engage in the complex biochemical reactions that power our thoughts, our movements, our very existence. It's like having an orchestra of incredibly potent, yet quiet, instruments. They possess immense potential, but they need a conductor, a purpose, to awaken their true capabilities. And this brings us to the heart of our contemplation: consciousness. From these fundamental sleeping atoms, organized in such an exquisitely complex way, how does this spark of awareness arise? Is there a subtle frequency, a unique vibrational pattern that emerges when matter reaches a certain level of organization? We are, after all, composed of the same elemental building blocks as the stars, yet we experience, we feel, we perceive, we wonder. It's as if the universe, having forged these atoms, then arranged them in a way that allowed for something entirely new to blossom, the awareness of being. Our bodies are like intricate instruments, built from materials that journeyed across the cosmos. The atoms within us are the strings and keys, waiting for the conductor of consciousness to bring forth a symphony of life. Each breath, each heartbeat, each thought is a note played on this cosmic instrument, a melody composed of stardust and awareness. If our physical bodies are collections of sleeping atoms, what happens to this fundamental matter when the spark of life fades? Does the atom's potential truly disappear? When you look at your hands, can you feel the connection to the cosmos? The universe is a grand cycle of creation and dissolution. The atoms that form us are temporary arrangements, destined to return to the cosmic dance. And so, we find ourselves here, at the cusp of understanding a profound truth about ourselves and the very fabric of existence. We are, in essence, a borrowed stardust, animated for a fleeting moment. Think about it. Every breath you take, every beat of your heart, is a testament to an incredible exchange. Life itself is a masterful act of energy utilization. Sunlight, captured by plants and then passed along through the food chain, or the chemical energy stored in the food we eat. It's all fuel. This energy is what allows atoms, those fundamental building blocks, to be temporarily coaxed into intricate, organized structures. They're arranged into the delicate latticework of your bones, the pulsing network of your veins, the astonishing complexity of your brain. It's a temporary, vibrant assembly held together by these invisible currents of energy. Within us, this energy exchange is happening at an astonishing rate, a constant hum of activity we call metabolism. Imagine your body as a tiny, bustling city. Atoms are like the citizens, constantly moving, interacting, and being energized or de-energized. Through metabolic processes, these atoms are being nudged into higher, more energetic states, allowing them to perform their functions to build and repair. Then, as they release that energy, they settle back into a more stable, ground state, ready to be re-energized. It's a ceaseless dance of excitation and relaxation, a constant ebb and flow of energy that keeps us alive, keeps us vibrating with life. But not all atomic transformations are so gentle. Some atoms carry a different kind of instability within their very core. These are the radioactive isotopes. Their nuclei are like tiny, overstuffed suitcases, holding just a bit too much energy. Eventually, something has to give. Spontaneously, without any external push, these unstable nuclei will decay. They shed particles, they emit energy, often in the form of radiation, and transform into different, more stable forms. It's a fundamental process, a natural shedding of excess, a way for the universe to find equilibrium. And this is where the grand cycle truly reveals itself. When we speak of decomposition, of things returning to the earth, we're really talking about this universal recycling program. When living things die, their complex arrangements of atoms are broken down. Microbes, fungi, the very elements themselves, take these atoms apart, returning them to the soil, the air, the water. Similarly, radioactive decay is constantly at work, transforming elements over vast stretches of time, releasing energy that has shaped our planet and continues to do so. These processes ensure that the atoms that once comprised a mighty redwood, or a fleeting butterfly, or even you and I, are not lost. They are released, made available once more to be woven into new tapestries of existence. Life is like a temporary eddy in a vast river. The water molecules, those fundamental atoms, are always flowing, always moving, but for a time they gather and form a distinct, vibrant shape. They swirl and dance, creating a beautiful, temporary pattern before rejoining the main current, carried onward by the river's ceaseless flow. If our atoms return to the cosmic pool, if they are recycled and reformed, what happens to the information, or this pattern, that constituted our unique existence? Where does the essence of our being go when the temporary arrangement dissolves? Beyond the familiar forces, quantum mechanics reveals a subtler, more profound connection between particles, a spooky link that transcends space and time. Let's delve into something truly extraordinary, a phenomenon that still tickles the edges of our understanding: quantum entanglement. Imagine, if you will, two tiny particles, perhaps electrons or photons, that have interacted in a very specific way. Once they've shared this intimate dance, they become entangled. It's as if they've forged a silent, unbreakable pact, a shared destiny. No matter how far apart we pull them, across a laboratory bench, across a continent, or even across galaxies, they remain intrinsically linked. Their fates are intertwined, like two threads woven from the same luminous fabric, forever bound by their initial encounter. It's a connection so deep, so fundamental, that it seems to whisper secrets across the vast emptiness of space. Now, here's where it gets truly mind-bending. When we measure a property of one entangled particle, say its spin, whether it's spinning up or down, something remarkable happens. At the very instant we observe this property in one particle, the state of its entangled partner is instantaneously determined, no matter the distance separating them. It's as if the universe itself holds its breath, and then, in a single, unified breath, the second particle assumes its corresponding state. If one is found to be spinning up, its partner must be spinning down, and vice versa. This isn't about information traveling between them, it's about their states being inherently correlated from the moment of their entanglement, a shared reality that unfolds simultaneously. The implications of this spooky action at a distance, as Einstein famously called it, are nothing short of revolutionary. For starters, it hints at the possibility of unbreakable communication. Imagine sending messages not through wires or radio waves, but through these entangled links instantaneously across any distance. Then there's the burgeoning field of quantum computing, where entanglement is a cornerstone, allowing for calculations that are utterly impossible for even the most powerful classical computers. Beyond technology, it forces us to reconsider the very nature of reality, suggesting that perhaps separateness is more of an illusion than a fundamental truth, and that the universe might be far more interconnected at its deepest levels than our everyday senses perceive. And this is where our journey tonight takes a more contemplative turn. If fundamental particles can exist in such a deeply intertwined state, sharing information and influencing each other instantaneously across vast cosmic distances, could something similar be at play within our own consciousness? Could entanglement be a subtle, perhaps even a primary, mechanism for the interconnectedness of minds? Is it possible that our subjective experiences, our shared awareness, or even moments of profound empathy, are not merely coincidences but echoes of a deeper quantum symphony? The idea that our inner worlds might be subtly linked, like entangled particles vibrating in unison, is a thought that truly hums with possibility. Imagine two coins flipped simultaneously, but they are magically linked. If one lands on heads, you instantly know the other must have landed on tails, no matter how far apart they are when they land. If particles can be so intimately connected, what about the vastness of the universe? Are there connections we haven't even begun to perceive, a cosmic consciousness woven into the dark? What does the word connection mean to you? Error generating script section 500, an internal error has occurred. Please retry or report in HP by developers. Generative AI, Google guided troubleshooting. We've explored the sleeping atoms and the mysterious dark of the cosmos. Now let's turn inward, to the most profound mystery of all, consciousness itself. What is this feeling of being? This inner landscape of thoughts, emotions, and sensations? Philosophers have wrestled with this for centuries, calling it the hard problem of consciousness. Imagine trying to explain the vibrant crimson of a sunset, or the bittersweet ache of a memory, purely in terms of electrical impulses and chemical reactions. It's like trying to describe the taste of honey by listing its molecular components. You can know all the ingredients, but you miss the gully's essence, the subjective experience of sweetness. How does the firing of neurons, the dance of neurotransmitters within the intricate circuitry of our brain, give rise to the rich tapestry of our inner world? It's a question that hovers at the edges of our understanding, a whisper in the vast halls of neuroscience. Neuroscience, of course, offers us a beautiful, intricate picture of the brain as a biological machine. We see the neurons, those delicate, branching messengers, firing in complex patterns. We understand how neurotransmitters, like tiny chemical keys, unlock different states of being, from the calm hum of serotonin to the sharp focus of dopamine. We're mapping the intricate networks, the highways and byways of neural activity, and we're beginning to see how these physical processes correlate with our conscious states. It's a remarkable achievement, like charting every wire and circuit in a colossal, living computer. Yet, even with this exquisite map, the question remains, where does the feeling itself reside? Where is the Allah's awareness born from this electrochemical symphony? And then, we venture into more speculative, yet utterly captivating, territories. Some thinkers wonder if the very fabric of reality, the quantum realm, might hold clues. Could consciousness be linked to quantum phenomena like entanglement, where particles remain connected no matter the distance, or quantum coherence, that delicate state of unified existence? Imagine consciousness not as something produced by the brain, but perhaps as something the brain tunes into, like a finely crafted instrument resonating with a universal hum. These ideas are still on the frontier, whispers of possibility, but they invite us to consider that consciousness might be woven into the very warp and weft of existence, not just an emergent property of complex matter. This leads us to even more ancient and profound ideas, like a panpsychism. This is the notion that consciousness, or at least a primitive form of it, isn't exclusive to brains. Perhaps it's a fundamental property of the universe, present in some nascent form even in the seemingly inert, the sleeping atoms we spoke of earlier. Imagine a universe where everything has a flicker of awareness, a subtle sentience. It's a radical thought, turning our everyday understanding of consciousness on its head. It suggests that the universe isn't just a collection of objects, but a vast, interconnected web of experiencing entities, from the smallest particle to the grandest galaxy. Our brain is like a sophisticated radio receiver. It picks up cosmic signals, but the source of the signal, the broadcast of consciousness, remains a profound mystery, perhaps originating from the very fabric of reality. If consciousness is so pervasive, or so linked to the fundamental nature of reality, could it influence the sleeping atoms in ways we don't yet understand, perhaps even affecting the dark? What does consciousness feel like to you, in its purest form? In the quantum world, the act of observation itself seems to influence the outcome, blurring the lines between the observer and the observed, the conscious and the material. We've been exploring the quiet hum of atoms, the subtle dance of energy. Now, let's gently nudge open a door into one of the most profound, and frankly, of bewildering aspects of quantum mechanics, the observer effect. It's here, in this subatomic realm, that the very act of looking seems to change what we see. Imagine a world where reality itself is a shy dancer, only revealing its steps when it feels the gaze of an audience. That's a little like what happens at the quantum level. Quantum entities, like electrons or photons, possess this astonishing ability to be both a wave and a particle almost simultaneously. Think of a wave on the ocean spread out, encompassing many possibilities, a gentle ripple across the surface. Then, picture a tiny solid pebble precisely located, a distinct point in space. Quantum objects can be both these things. They exist as a probability wave, a kind of smeared out potential, until something interacts. This brings us to that famous, almost mythical, experiment, the double-slit experiment. It's like a cosmic riddle whispered in a laboratory. When we fire these quantum entities, like electrons, at a barrier with two narrow slits, and we don't watch which slit they go through, they behave like waves. They spread out, pass through both slits at once, and create an interference pattern on a screen behind, a signature of wave-like behavior, like ripples from two pebbles dropped in a pond overlapping. But here's the twist. The moment the universe seems to blush, the instant we try to detect which slit each electron passes through, the wave collapses. They suddenly decide to be particles, choosing one slit or the other, and the interference pattern vanishes, replaced by two distinct bands, just as you'd expect from tiny bullets. Our observation, our measurement, forces a change in their fundamental nature. So, what exactly counts as an observation, or a measurement, in this strange theater? Does it need a conscious mind, a thinking being, to be present? This is where the philosophy gets really intriguing. In the early days, it was thought that any interaction, any disturbance that records information about the particle's path, would cause this collapse. But as we delve deeper, the question lingers: is there something special about consciousness itself that plays a role? Is it the awareness of the measurement, the act of a knowing that collapses the wave? Or is it simply the unavoidable physical interaction of the measuring device? The debate still echoes through the halls of physics, a soft hum of unanswered questions. And the implications for our understanding of reality are simply breathtaking. If the very act of observing can influence, even determine, the state of something at its most fundamental level, then perhaps reality isn't this solid, fixed stage that exists independently of us. Maybe, just maybe, the universe is a co-creation, a dance between potential and actuality, where our consciousness, our attention, our interaction, plays a vital role in bringing forth the experienced world. It suggests that what we perceive as solid, concrete reality might be, in part, a manifestation of what we are looking for. Imagine a shy creature that only reveals its true form when it knows it's being watched. The quantum world is like that. The possibility wave only solidifies into a definite particle when an observer interacts with it. If observation shapes reality at the quantum level, could a collective consciousness, or even the sleeping potential of the universe, interact with the mysterious dark matter and energy in ways we can only begin to intuit? What does it mean to observe something? We've explored the sleeping atoms and the universe's own deep pauses. Now let's consider our own nightly descent into sleep, a state that mirrors the cosmos in profound ways. Sleep, you see, isn't just a luxury, it's a biological imperative, a fundamental dance of restoration. Imagine your body as a bustling city, constantly building, repairing, and maintaining its intricate infrastructure. During the day, this city is alive with activity, with every street and building working tirelessly. But at night, when we surrender to sleep, it's as if the city gates close, and a quiet, dedicated workforce emerges. This is when our cells mend themselves, like tiny artisans meticulously repairing worn pathways. Our memories, those precious souvenirs of our waking hours, are sorted, filed, and strengthened, weaving themselves into the tapestry of who we are. It's a profound act of recharging our biological batteries, ensuring we're ready for the next dawn. Now, let's tune into the symphony of our sleeping minds, the subtle shifts in our brain waves. As we relax, our brain begins to hum at a slower, gentler frequency, often in the alpha range, like a soft, ambient melody. Then, as we drift into the lighter stages of sleep, we enter the theta waves, a more dreamlike, fluid state, where the boundaries between thought and feeling can blur, like mist rising from a calm lake. And finally, in the deepest slumber, we reach the delta waves, a powerful, slow rhythm, the very bedrock of physical restoration, a profound stillness where the deepest healing occurs. These aren't just electrical patterns. They represent altered states of consciousness, doorways to different ways of being. During sleep, our brain, that incredibly complex universe within us, undergoes a fascinating transformation. Certain regions, like the prefrontal cortex responsible for our executive functions and conscious decision making, quiet down, becoming less engaged, almost like atoms settling into their above-ground state, a state of minimal energy. But this isn't a shutdown. Instead, other areas, particularly those involved in memory consolidation and emotional processing, become remarkably active. It's like a dedicated maintenance crew taking over the city, working diligently in the quiet hours to ensure everything is running smoothly for the day ahead. This dynamic rebalancing is crucial for our cognitive and emotional well-being. And then there are dreams, those ephemeral narratives woven from the threads of our subconscious. When we dream, our minds are not simply idle. They are actively processing, exploring, and perhaps even communicating with us from a deeper, less structured realm. It's as if the conscious mind, with its rigid logic and linear thinking, takes a back seat, allowing the subconscious to express itself in a language of symbols, emotions, and unexpected juxtapositions. These dreams can be like glimpses into a hidden library filled with forgotten stories, unexpressed desires, and profound insights, a different mode of awareness that speaks in whispers and images. Sleep is like the earth turning away from the sun for a while. It's a period of rest, of quiet processing, where the planet's energies are renewed, preparing for the next cycle of light and activity. It's a cosmic exhale, a chance for everything to settle and regenerate. As we drift into sleep, our individual consciousness seems to dim. But what if this dimming allows us to tap into subtler energies, or even connect with the vast, dark ocean of universal consciousness? The moments just before falling fully asleep, the hypnagogic state, are a liminal space, a beautiful threshold where the conscious mind begins to dissolve into the subconscious. It's that exquisite moment, isn't it? When the day's sharp edges begin to soften, and the world outside gently recedes. This precious interval, this hypnagogic state, is like a secret garden gate, just ajar, beckoning us into the deeper, wilder territories of our own being. Here the usual anchors of our waking thoughts loosen their grip, and a different kind of perception begins to bloom. You might notice fleeting images, like fragments of forgotten photographs or vibrant, abstract patterns swirling behind your eyelids. Sometimes, you'll hear whispers, a phantom voice, or a snatch of music that seems to materialize from nowhere. And then there are those sudden, involuntary muscle contractions, those hypnagogic jerks. That can feel like a stumble on an invisible staircase, pulling you back just for a second, before you surrender once more. It's a sensory symphony, played in the quiet theater of your own mind. In this twilight zone, the rational, analytical part of our mind, the part that meticulously sorts and categorizes, begins to sigh and settle down. It's like a busy librarian finally closing up shop for the night. This allows the more fluid, intuitive currents of the subconscious to rise to the surface. Memories, long tucked away, might appear not as linear narratives, but as vivid sensations or symbolic encounters. Archetypes, those ancient patterns of human experience, can emerge, dressed in the raiment of your personal history or cloaked in universal mystery. It's a beautiful, untamed landscape where thoughts don't march in single file, but dance and mingle, creating a rich tapestry of inner experience. This state has long been a wellspring of profound creativity. Think of artists who've woken with a fully formed melody, writers who've found the perfect turn of phrase, or scientists who've grasped a complex solution in the blink of an eye, just as they were drifting off. Salvador Dali famously used this state, holding a key above a plate. As he fell asleep, the clatter of the key would jolt him awake, capturing the images that flickered at the edge of consciousness. It's as if the subconscious, unburdened by the constraints of logic, can forge entirely new connections, weaving together disparate threads of knowledge and experience into something entirely novel and illuminating. These moments are fertile ground for breakthroughs and unexpected insights. We can think of this hypnagogic state as a gentle, voluntary immersion into the dark, not a frightening darkness, but the rich, fertile darkness of the unmanifest, the realm of pure potential. It's where the usual rules of perception and logic are suspended, allowing us to explore the vast, uncharted continents within ourselves. It's a space where the boundaries between self and other, between thought and reality, can become beautifully blurred, offering a glimpse into a deeper, more connected existence. It's a quiet surrender, a trusting dive into the ocean of your own inner universe. The hypnagogic state is like standing at the edge of a vast, dark forest just as twilight descends. The familiar paths fade, and the shapes of the trees become mysterious, hinting at hidden wonders within. You can't quite see what lies beyond, but there's a sense of immense possibility, a quiet hum of unseen life. If this transition state allows for such profound inner exploration, could our intention or focus during these moments subtly influence the very fabric of our perceived reality, or even the sleeping atoms around us? What kind of imagery do you see when you're about to fall asleep? Everything in the universe vibrates, from the smallest atom to the largest galaxy. What if consciousness itself is a form of resonance, a frequency that connects us all? It's a thought that hums, isn't it? This idea that nothing is truly still, even the most solid-seeming objects, the very ground beneath our feet, are in a constant, energetic dance. Atoms, those tiny building blocks we learned about in school, aren't like little marbles sitting idly. Oh no. They're more like miniature tuning forks, each one vibrating at its own specific, unique frequency. Molecules, those clusters of atoms, also possess their own resonant signatures, their own subtle song. It's this ceaseless motion, this inherent vibratory nature, that gives matter its form and its character. Imagine a vast, silent orchestra, where every single instrument, from the tiniest bell to the deepest drum, is always playing its own distinct note, its own fundamental frequency. And we, as conscious beings, perceive so much of this vibrational world through sound. Sound, after all, is nothing more than pressure waves traveling through a medium, reaching our ears as vibrations that our brains interpret. Think about it. A deep bass note can rumble in your chest, a high-pitched whistle can prickle your skin, and a gentle melody can wrap around you like a warm embrace. Different frequencies, different wavelengths, evoke entirely different emotional and even physical responses within us. It's as if our very bodies are designed to tune in to these sonic landscapes, to feel the subtle shifts in energy that sound represents. Now, let's stretch our minds a little further, out into the grand expanse of the cosmos. Scientists have detected what they sometimes call a universal hum, a faint, persistent background resonance that permeates the universe. Some speculate this might be linked to the mysterious dark matter and dark energy that we can't directly see, or perhaps even to the constant churn of vacuum fluctuations, the very emptiness of space teeming with potential energy. It's as if the entire cosmos is breathing, emitting a low, steady frequency, a foundational tone upon which all other cosmic music is played. And this brings us to the heart of our contemplation. Could consciousness itself be of waveform, not just a passive receiver of these cosmic frequencies, but an active participant, capable of resonating with them, of broadcasting its own unique signal? Imagine our consciousness as a complex, intricate wave, capable of interacting with the universal hum, perhaps even influencing it in subtle ways. It's like our awareness is a finely tuned radio, able to pick up not just the local stations but also the faint, ancient broadcasts from across the universe. Think of the universe as a vast, interconnected symphony. Each atom, each star, each being is an instrument playing its unique note, contributing to the grand, overarching harmony. Our consciousness is our ability to tune into this music. So, if consciousness is indeed a form of resonance, a frequency that can interact with the universe's own subtle vibrations, could our focused intention, our conscious frequency, be a subtle force that interacts with the universe's own sleeping frequencies, perhaps even influencing the mysterious dark? What is a sound frequency that you find particularly soothing or powerful? We've spent this journey exploring the dark as a scientific enigma. But perhaps this darkness is not an absence, but a presence, the potential for everything that is not yet manifest. It's a curious thought, isn't it? That the very things we perceive as empty, as void, might actually be brimming with this unseen possibility. Philosophers, for millennia, have pondered the nature of this primordial state, this absolute nothingness. They've seen it not as a lack, but as the fertile ground from which all things spring. Imagine the universe before the first spark, before the first atom coalesced. Was it truly empty, or was it a vast, silent ocean of pure potential, holding within it the blueprints for stars, for galaxies, for every whisper of existence? This dark is the ultimate source code, the canvas upon which reality is painted, the silent hum before the symphony begins. It's the pregnant pause in the cosmic breath, pregnant with everything that could ever be. And when we look out into the cosmos, we find echoes of this philosophical idea in the very fabric of space. Dark matter and dark energy, these elusive cosmic components, aren't just missing pieces in our celestial puzzle. Instead, consider them as the invisible scaffolding of reality. They are the unseen architects, the silent, pervasive forces that hold galaxies together, that push the universe apart, allowing the luminous, the visible, the unknown to take shape and evolve. They are the deep, resonant hum beneath the visible light show, the quiet strength that underpins all that we can perceive. Without this profound, unseen foundation, our universe, as we know it, simply wouldn't hold its form. It's the deep, dark roots that nourish the brightly flowering branches. This concept of the dark, as a source of potential, isn't confined to the vastness of space. It resonates deep within our own inner landscapes too. Think about your subconscious mind, that vast, often uncharted territory within. It's the womb of creativity, the silent incubator of intuition, the reservoir of all that you could be. This inner dark is where dreams are born, where insights flicker into being, often during those quiet moments of rest, of introspection, or even during sleep. It's in these states of perceived darkness, when the external world fades, that our inner potential can truly begin to stir and awaken. It's like a deep, still pool, reflecting not what is, but what is waiting to emerge. This brings us to a fundamental philosophical distinction, the difference between that potential and actuality. The dark represents the realm of infinite possibility, the boundless what-if. It's the unwritten story, the unplayed melody, the unpainted canvas. Actuality, on the other hand, is what has manifested, what has taken form and become manifest in the light of our perception. The dark is the realm of pure, unadulterated could be, a space of pure, unformed energy and idea, waiting for the right conditions, the right intention, the right resonance to step into existence. It's the universe holding its breath, ready to exhale a new creation. The dark is like the fertile soil before a garden blooms. It appears empty and still, but it holds all the potential for life, for color, for form, waiting for the right conditions to express itself. It's the quiet promise before the dawn. If the dark holds such immense potential, and our consciousness is a form of resonance, how can we consciously attune ourselves to this vast reservoir of possibility? We've seen how observation can influence quantum events. What if conscious intention, focused and clear, can also subtly interact with the universe's sleeping atoms and its vast, mysterious dark? It's a thought that tickles the edges of our understanding, isn't it? Let's gently explore this idea. When we talk about focused attention, we're not just talking about staring intently at something. It's a deep internal gathering of our mental energy. Neuroscientifically, when we focus, our brain waves shift, becoming more synchronized, more coherent. It's like tuning a radio to a specific station, filtering out the static of distraction. This focused state has tangible effects on our own biology, influencing our stress hormones, our immune responses, even the very way our cells communicate. It's as if our internal landscape, when held with clear intention, becomes a more fertile ground for well-being, a subtle dance between mind and matter within our own being. Now, let's revisit that fascinating observer effect. Remember how a particle, existing in a haze of possibilities, snaps into a definite state only when observed. The question that arises, like a whisper in the quiet, is whether it's merely the act of measurement that causes this collapse, or if it's something deeper. Could it be consciousness itself, the very awareness that perceives, that acts as the catalyst? Imagine a vast, unwritten symphony of potential, and our focused consciousness is the conductor, raising its baton, bringing a specific melody into existence from the silent potential of the score. It's a profound idea, suggesting that our awareness isn't just a passive witness, but an active participant in the unfolding of reality. This leads us to the more speculative, yet utterly captivating, realm of a subtle energy and quantum field interaction. If the universe is permeated by quantum fields, like an unseen ocean of vibrating energy, could our focused consciousness, our intention, be like a ripple sent across that ocean? Perhaps our directed thoughts, imbued with emotional resonance, create subtle energetic patterns that interact with these fundamental fields. It's not about brute force, but a gentle, resonant tuning. Think of it like humming a specific note. It can cause a nearby crystal glass to vibrate sympathetically. Our focused intention might be a similar kind of resonance, a subtle energetic signature that nudges the probabilities within the quantum foam, influencing what emerges. And if this is so, what does it say about our role as co-creators of reality? It suggests that we are not merely passengers on a predetermined journey, but active artists painting on the canvas of existence. Our individual intentions, when focused and amplified by collective consciousness, might contribute to the larger patterns of our shared reality. It's like a vast, interconnected web where each conscious thought, each focused intention, sends subtle vibrations throughout the entire structure, influencing the overall design. We are, in essence, weaving our own threads into the grand tapestry of what is and what will be. Imagine the universe as a vast, responsive canvas. Our conscious intentions are like gentle brushes, adding strokes of color and form to the existing patterns, subtly influencing the unfolding masterpiece. As we prepare to conclude this journey, how can we carry this understanding forward, integrating the wisdom of the sleeping atoms and the mysterious dark into our waking lives? What is one intention you hold for yourself today? We've journeyed through the known and the unknown, the visible and the unseen. The greatest wisdom may lie not in finding all the answers, but in gracefully embracing the profound mystery. And here we are, at the quiet edge of this particular chapter, with the universe still whispering its secrets. We've talked about dark matter and dark energy. These are invisible architectures that hold galaxies in their silent ballet. And we've touched upon consciousness, that most intimate and yet most elusive of experiences. It's easy to feel a little overwhelmed, perhaps even a touch lost, when we consider the sheer raw vastness of what we don't know. But in that very not knowing, there's a surprising comfort, isn't there? It's like realizing you don't need to map every single star to appreciate the night. Accepting the unknown isn't a surrender, it's a liberation. It frees us from the exhausting pursuit of absolute certainty, allowing us to breathe in the immensity of existence with a lighter heart. It's an invitation to simply be with the questions, to let them hum softly within us, like a deep, resonant chord. This acceptance naturally blossoms into a state of thus living with wonder. Think about a child encountering a dewdrop for the first time, its tiny world reflecting the vast sky. That pure, unadulterated awe is a state of being we can cultivate. It's about looking at the intricate patterns on a fallen leaf, or the way sunlight filters through ancient trees, and feeling that same sense of profound curiosity. It's recognizing that the universe, in its grand design and its smallest particles, is a continuous unfolding of marvels. This wonder isn't just a fleeting emotion. It's a way of orienting ourselves, of seeing the extraordinary woven into the fabric of the everyday. It's about asking, what if, and how does this work, not with an expectation of a definitive answer, but for the sheer joy of the exploration itself. And as we marvel, we also begin to feel it more profoundly, this deep, undeniable interconnectedness of all things. From the sleeping atoms that form the very ground beneath us, to the unseen forces that bind the cosmos, everything is woven together. The same stardust that ignites distant nebulae is also present in the cells of our bodies. The silent hum of the universe is the same quiet rhythm that beats within our own hearts. There's no true separation, no isolated island of existence. We are all part of a unified tapestry, a grand breathing organism. This understanding can shift our perspective, fostering compassion not just for other beings, but for the entire web of life, for the very fabric of reality itself. This brings us to the heart of it all, cultivating a state of conscious presence. It's about tuning into the subtle frequencies of life, even in the moments of apparent stillness. It's being fully here now, with whatever arises. Imagine sitting by a quiet lake, not trying to change the water or control the ripples, but simply observing the gentle dance of light upon its surface. This mindful awareness allows us to connect with the deeper currents of existence, to feel the quiet pulse of the universe within us. It's in these moments of pure presence that the mystery doesn't feel like an absence, but like a rich, vibrant fullness. It's a state of being where we are not just observers, but participants, deeply attuned to the subtle symphony of reality. Embracing the mystery is like gazing at a star-filled night sky. You can't grasp every distant galaxy, but you can feel the immensity, the beauty, and the quiet wonder of it all, simply by being present under its vastness. As this exploration gently concludes, let us carry this sense of wonder and connection into our rest, allowing the sleeping atoms of our being to integrate this journey. What is one word that describes your feeling about the universe right now? And so, we arrive at the gentle conclusion of our exploration, a transition from cosmic inquiry to the profound stillness of sleep, where the universe within us finds its own quiet resonance. Remember those sleeping atoms we spoke of, the ones holding their breath in ground states, brimming with potential energy like seeds waiting for the sun. We saw how even in their apparent stillness, there's a vibrant hum of zero-point energy that whispers of constant, subtle activity. It's as if the very fabric of matter, down to its most fundamental particles, is perpetually dreaming, holding within it the memory of motion, the promise of transformation. This quiet energy, this latent power, is the bedrock of everything we perceive, a universe in miniature, sleeping soundly within the solid form of a stone, or the beating heart of a human. And then there's the Dar's mysterious dark, the cosmic ocean that cradles galaxies, the unseen architect of the universe's grand design. We touched upon dark matter, that invisible scaffolding that holds galaxies together, and as dark energy, the relentless force pushing the cosmos ever outward, like a cosmic sigh that never ends. It's a reminder that what we see, what we can measure, is but a faint shimmer on the surface of a vast, unfathomable reality. This darkness isn't empty, it's pregnant with potential, a silent partner in the cosmic dance, shaping the grandest structures from the subtlest influences. What's truly wondrous is how these seemingly disparate threads, the sleeping atoms within us, and the duller's mysterious dark that surrounds us, are not separate at all. The principles that govern the smallest quantum fluctuations echo in the vast expanse of the cosmos. The same forces that bind a proton, that hold an electron in its orbit, seem to be mirrored in the gravitational embrace of galaxies, and the expansion of spacetime itself. It's as if consciousness, too, operates on these dual frequencies, connecting the intimate landscape of our inner world to the boundless theater of the universe. Now, as we prepare to surrender to the embrace of sleep, let these insights settle within you like gentle dew. Allow the concepts of sleeping atoms and the mysterious dark to weave themselves into the tapestry of your rest. Let your own atoms, your very being, align with that quiet, pervasive hum. This is not an act of forgetting, but of integration, a conscious letting go into a state where the universe within and without can harmonize, where your inner universe can resonate with the silent, profound rhythm of the cosmos. Allow yourself to drift now, like a tiny particle settling into its most stable, peaceful state. The journey has prepared you for this moment of deep rest, where your inner atoms resonate with the quiet pulse of the cosmos. May the insights from the sleeping atoms and the mysterious dark bring you profound peace and rejuvenating rest. What is one thing you will remember from this journey? We have journeyed from the fundamental vibrations of sleeping atoms to the enigmatic expanses of the mysterious dark. We have seen how the universe orchestrates its grand symphony through unseen forces, from the quantum realm to the cosmic web. We explored the birth of elements in stellar furnaces, the unseen scaffolding of dark matter, and the accelerating push of dark energy, and we found echoes of this cosmic dance within our own being, in the atoms that form us and the cycles of life and rest. It's a story woven from starlight and silence, from the smallest tremor to the grandest cosmic sweep. The universe, in its vastness and its intricacy, offers us a profound mirror. The sleeping atoms within us, seemingly inert, hold boundless potential, much like the dark matter and dark energy that shape the cosmos. Our consciousness, a delicate frequency, bridges the gap between the physical and the ephemeral, a whisper in the grand cosmic hum. To embrace the mystery is to acknowledge our deep connection to this grand, unfolding existence. It is to understand that in our stillness, in our quiet moments, we are not separate, but part of the same fundamental, resonant fabric that binds the smallest particle to the farthest star, a silent, interconnected song. As you drift into slumber, or as you return to your day, I invite you to share your reflections. What resonated most deeply with you? What insights did you glean from the sleeping atoms or the mysterious dark? Please share your thoughts in the comments below. Your presence and your reflections nourish this community and deepen our shared exploration. Let us continue to grow together, like roots reaching for the hidden water beneath the soil. Now, let the gentle rhythm of your breath guide you into a deep and restorative sleep. Feel the stillness within, the quiet hum of your own atoms at rest, like tiny stars settling into their orbits. Allow the vastness of the cosmos to cradle you, the mysterious dark to envelop you in its velvet peace. May your dreams be filled with wonder and renewal, with the soft glow of distant nebulae and the silent wisdom of ancient galaxies. Sleep deeply, beautiful souls. Sleep peacefully. Good night.